Hi, Daniel. Daniel who? Daniel who? Cheesy MK got time. What the freaking doodle? Can I request? Request what, Daniel? Okay, guys, let's get the live up to 1,000k likes, and then we might just consider requests after we have reached 1k. Furthermore, guys, let's yeah, I've got a live goal. It would be nice if that live goal would be supported there. Yeah, so let's double tap on the screen there hectically. I see. So Daniel, what grade are you in, and what would you like to request about? If I can just get a idea there in the comment section. Daniel in grade 8. Really? What do you want to ask about, Daniel? Kidding. Equations and expressions in grade 8, really? Now that is interesting. Super interesting. Very interesting. Oh, in term 1, that's what I'm asking. Grade 8 with equations and expressions in term 1. That is very interesting. Okay, guys, we are about to reach 1k likes. So Daniel, you can come up with your request. Let's hear it. It should be interesting. This is very interesting to me. A grade 8 with equations and expressions. Which school do you attend? Daniel,
Yes,
what's up?
good.
Good. Are you, first and foremost, let me just establish, are you really in grade 8, or are you just trolling?
Yes, I'm really in grade 8.
You are in grade 8.
Yes,
Yeah, so if you are in grade 8, you are saying you have a request, and your request is specifically about expressions and equations.
yes,
That's very interesting. So you guys are doing expressions and equations now.
no.
Okay. So what's happening?
I just want to understand them.
You want to understand them.
Yes,
So that means you've been going through them.
yes,
Okay. So, do you have a specific question about anything with equations and expressions?
Yes, I want to know the law of exponents.
The law of exponents. Okay.
Yes.
Okay. So, what do you know though? Like, let's establish what you know before I can share with you maybe more. What do you know?
Nothing.
Hi man. How can Hi man Daniel, when are you killing me with this thing? You were saying hi man. Daniel, you are killing me. You're killing me softly here. You want to know about expressions, you want to know about equations. See, the thing is, your question is it's very broad. So you want to know about you want to know about exponents specifically.
Yes.
Okay. All right. If you want to know about exponents, then I'm going to expose you to it, and then yeah, we'll take it one step at a time. So firstly, before anything, hopefully you know how an exponent is represented. So here is a general sort of like a form, your exponential form. So we call this, what do we call this? Do you know, Daniel? This and this and this.
Base and exponent.
Yeah, there we go. Base and exponent. Why am I finding it very hard to believe that you are in grade 8 when something is telling me that something is off. Okay, so that's a base. That is an exponent, right?
Yes.
Yeah. Then we say the entire combination is what we refer to as a power. Okay. Yeah. So this is a base. This is an exponent. And we call the entire thing a power, right?
Yes.
So if, for instance, we are saying 2 to the power 3, hopefully you know that this is exponential form. When we expand it, this means that what are we doing? We are multiplying by base 2 this many times because of the exponent, because this reflects how many times do we multiply 2 by itself, right?
Yes.
So this is called exponential form. And then we say this is expanded form. So exponential form, and then this we call expanded form. And obviously, what is 2 times 2 times 2, Daniel?
8.
Exactly. All right. So that means, in other words, this 8 that you see here, we usually say, if we say it is 2 times 2 times 2, this is 8 being expressed as a product of prime factors. Okay. Do you know what a prime number is, Daniel?
Yes.
What is a prime number?
It is a number with only 2 factors.
Okay, very good. Okay, very good. Prime number is a number with only 2 factors. What are those factors?
1 and itself.
Okay, all right. So I think we are getting somewhere here. Or we are already somewhere. Okay. So when you are dealing with exponents, there are what we call the laws of exponents. Okay. You know them most, Daniel.
Yes.
Yeah. That's why I'm saying when you are trolling here, you know what you know. I don't know why you are asking what you know. Why are you asking what you know, Daniel?
No, I don't really know them too much.
Yes, come on. I don't really know them. Oh, you don't really know them, but they know you.
Yes.
This guy, man, you are a funny man, man. Okay, so what's law number one then, Daniel? You tell me. What does law number one say of exponents?
When we have the same basis,
Mm-hmm.
we multiply the exponents.
When we have the same basis, we multiply the exponents. Are you hearing what you are saying? When we have the same basis, we multiply the exponents. Are you hearing what you are saying?
Yes.
Okay. So let's rephrase the wording. When you are multiplying same bases, okay, base A, base A, you are multiplying same bases. There are your exponents. What you do is you keep the base, the same base. So you keep the base and you add the exponents. So the law of multiplication of same bases where exponents are concerned says when you are multiplying same bases, you keep that one base, then you add the respective exponents. Okay.
Yes.
I hope this is what you were trying to say.
Yes.
When you are multiplying same bases, you keep the base, you add the exponents. So for example, if I say 2 times 2 to the power 3, you can see here that we have the same numerical basis, right?
Yes.
And what is happening here? We are multiplying the bases. So according to this law that we've just discovered, if we are multiplying same bases, then what do? We keep the base,
We-
and what do we do to the exponents?
1 multiplied by 3.
Ah,
1
ah,
plus 3.
Daniel, here is the law. We're saying when we multiply same bases, Daniel, we keep the base. But what do we do to the exponents when we are multiplying same bases? We do what to the exponents?
We add them.
We add them, not multiply them. Okay? So do you know what exponents exists for this 2? What is the exponent that is here for 2? You see the exponent for 2 here, but what is the exponent for this 2?
1.
But how can you say it's 1? Where do you see that? How do you know there's a 1 there? Do you see the 1, Daniel?
No.
But how do you know it's there? Who told you there's 1 there? So you believe that there's 1 there.
Yes.
Does your belief mean you also know that there's 1 there?
Yes.
Do you believe in God, Daniel?
Yes.
Have you ever seen him?
No.
But you believe he's there,
Yes.
even though you don't see him.
Yes.
That's very interesting. So this one, it is there, even though we don't see it. So when we are multiplying same bases, Daniel, again, what do we do? When we are multiplying same bases, what do we do?
We add them.
We keep the what first? What do
The
we keep?
base.
We keep the base the same, right? And then we do what to the exponent?
We add them.
Yes, we add them. So it's going to be 2 to the power 1 plus 3. What is 1 plus 3, Daniel?
4.
So it's 2 to the power 4. What is 2 to the power 4, Daniel?
16.
Okay. So Daniel, law number 1 of exponents, what does it say? In words.
8. When we have the same basis, when we multiply the same basis, we add the exponents.
Okay. All right. Don't forget that other part. When multiplying the same bases, we keep the base. We add the exponent. When multiplying same bases, right?
Yes.
We do what? We keep the base, we add the exponents. So let's not forget that. That is a law, that is a rule. And if we know the rule, we must apply the rule correctly every time. What happens when you break a law in South Africa, Daniel?
You get arrested.
You what?
You get arrested.
Oh, okay, you get arrested. Do you know what happens when you break laws in mathematics?
You get the wrong answer.
Exactly. And then what does the wrong answer do to you? When the answer is wrong. Exactly. Look at Justy. Justy, there in the comment section. Then you fail. Daniel, do you like failing? Daniel. Yo, Daniel is silent now. It's like, hey, I don't know if I struck the sensitive nerve there.
Yeah, I hear you.
Huh?
I hear you.
Yeah, you hear me, ne? You get the point. So that's why, Daniel, it's very important for you to know the law, understand the law, and then also apply the law correctly. Not just once, not just today, not just for not for the next few minutes, not for the next few hours, not until the end of the night, not until tomorrow, but you need to remember, apply the law correctly every single day of your life. You have learned this today. You have a moral responsibility to know this law forever. Otherwise, it's painful if you forget. The day you forget is the day that you will let go of many things, and it will be like you are in prison. Okay, let's move on. Are you ready to learn the next law of exponents, Daniel?
Yes.
So are you sure you are with me with the first law?
Yes.
Okay. Law number 2. And I think, Daniel, I'm going to end here with you today. Law number 2. A to the power m divided by a to the power n. So what's happening this time? we are doing what to the bases that are the same?
We keep the bases and subtract the exponents.
Okay, so when you are telling me what will happen. So initially I was trying to establish what are we doing this time around with the bases? We are dividing. We are not multiplying. So when we divide the same bases, as you have now then explained, what is the outcome of dividing by the same basis? You said we do what? Now you can repeat what you said initially. You said?
We keep the bases and subtract the exponents.
Very sweet. We keep the base, we subtract the exponents. Okay? Yeah. So for example, these are two ways of looking at this. This is the division sign written out. This is another way of saying a to the power m. You have it written as a fraction. This line means divide. Okay, so both ways are actually meaning the same thing. Okay. So an example there that maybe I can just put very quickly would be, let's say, 3 to the power 3 times 3 to the power 2 times 3 to the power 1. 3 to the power 2 times 3 to the power 1. No, not divide. This is multiply. 3 to the power 2 divided by, let's say 3 to the power 3 divided by 3 to the power, 3 to the power 3 divided by 3. So here we are actually doing what? We are dividing what? Bases that are the same. So if we're dividing same bases, you said to me, Daniel, if we are dividing same bases, what am I going to write then?
You keep the base 3.
Okay, I've kept it, and then what?
And subtract the exponent 3 minus 1.
3 minus 1. I'm asking you again, where does the 1 come from? So Daniel, you just believe that the 1 is there, hey?
Yes.
Yeah, you are a big believer, I see. What then is the answer? 3 to the power, what's 3 minus 1?
2.
And then what's 3 squared? 3 to the power 2 gives us what?
9.
9. Okay, there we go. So Daniel, I am going to hold it right there for you for this evening. I am not going to go any further. That was law number 1 and law number 2, of exponents. So I think what we have then learned from this law is that when dividing same bases, the important thing here is that we also keep the base, which is the same, and then we subtract the exponents. Okay. Yeah. That's pretty much roughly what I'm going to explain to you for now. All right. Okay, so Daniel, I know you asked a lot of things, but honestly, in this live, I will not be able to answer all of your questions. But I think, if anything, I believe you have the knowledge already. Maybe you were just trying to check with me if what you know, you actually know for sure. But I hope these first 2 foundational laws of exponents are clear for you. All right. And I don't know how it is that we will be able to meet and see each other again, but this is as much as I can give to you for this evening. So thank you so much. I appreciate you asking your question. I hope, yeah, it has at least been satisfying to the degree that it has been. Thank you, Daniel. Okay. All right, guys. Yeah. So that was Daniel. I think Daniel just, yeah, I'm a bit shocked because Daniel is in grade 8 and he came up here and he wanted to know about, what was it? He wanted to know about. He wanted to know specifically about, what is it? Expression. He wanted to know about expressions and equations, and he specifically wanted to know about exponents as well. So we have just touched on two important things. One, we've touched on the two basic fundamental laws of exponents. So I explained that grade 11s know that they are also at the moment or have been busy with exponents and cells, right? Grade 10s will be busy with exponents, I think, in the coming week if they haven't started doing so already. All right. Just in the comment section, what are you saying? Financial maths, grade 9. Financial maths, grade 9. Okay, guys, please support the live creator. There in the goal box there, I have pinned there, guys, my live goal. Please, the live goal. All right. Yeah, let's get the likes to 2000k and let 2k likes, 2k, so that I can accept the next guest request. Justy, you want to have a crack at financial math? Yeah, let's get the likes to 2k and then I can take the next guest request. Also, guys, like I said, my live goal there at the top, that will be epic, awesome, great. So I'm happy to take requests. Um, happy to take requests. I'm happy to take requests, but let's get it up to 2k likes first before I can do the next guest request. Do 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 do. Okay, wow, 1.5k there. We're slowly but surely getting to that 2k. Eusty. Is that the actual real name or is that like a TikTok street name?
Like it's my name in short.
It's your name in TikTok. Okay, no, that's fine. Let's stick to that so as to conceal your true identity. So, anyways, you have said in the comment section
Yeah,
financial maths.
financial maths. I mean, good night.
Oh, you in grade 9.
Yes.
Oh, so that means you are moneyed there. You have money.
No, we are being taught about this, and like I'm not understanding the teacher very well. So I think I can
You're not
understand you
understanding the
better.
teaching.
Yes, but I think I can understand you better. I don't know.
You think you can understand me better? No, I,
Yeah.
I think when you have too much faith in someone that you don't know.
Ish.
Have you have you have you have you
Like
have you been?
I've watched your life like before. So like
Oh,
I
you've watched a live before. Oh, okay.
yeah. So like
When was this? When did you watch a live before?
about my last year.
Oh, Boma last year. So you were in grade 8 that time.
Yes.
Nice. We watched the live when you were about to write exams or what?
Whenever, like, yeah, I was
Oh,
traveling.
whenever you could. Oh, okay. No, not necessarily that it was like before exam time.
No.
Oh, okay. No, it's just that most people they like coming through when it's about exam time, and then they become popular in my life.
Oh, yeah. Everyone wants to pass.
Yeah, yeah, but it's a pity that people don't realize that the whole passing thing is something that you need to build. It's something you build up to. You have to kind of. It's not something you can just do just before before an exam. Most people just want a quick fix. You know,
Yeah.
they don't want to be consistent throughout the year and maintain a certain consistency that builds. But anyways, let me not play the preaching game. Let's get straight to what you want to ask. You are doing financial maths in
Yes.
grade 9. So the
Yes.
things that you guys are getting exposed to are what in financial maths? Maybe you can talk to me about that.
Things like simple interest and compound
Mm,
interest. Yeah.
mm. Hi, Moss. You've got it, Moss. So why are you here? You've got it, Moss. Simple
Like,
interest, compound interest.
I just know the names of those things, but like I don't know how to.
You just know the names.
Yes.
Yo. Joe. Okay. So you want us to do damage control here.
Uh,
So do you have maybe some exercises that you were doing that you did at school? Maybe homework or whatever that you have been given or what have you. Maybe we can look at a few things from that. Maybe something you did not understand from that. So simple
okay.
interest, do you understand the concept of simple interest?
No.
Okay. So let's make an example. Let's say uh, you get 100 rand, right?
Yes.
It's money more that you've worked with before this one. You've been given such an amount of money before by someone, right?
Yes.
Yeah. So let's say you have 100 rand. It's with you, my guy, right? You
Yes.
decide that, hey, you want to save this money. But unlike all the other times, because most you in the past, you've gotten 100 rand. What you do, you try and put it somewhere for hiding there at home. Maybe you put it on in the shoe, you put it in a, I don't know, maybe in an old sweater jacket that you don't wear anymore, where you think no one will find it. Or maybe, I don't know, maybe you have a piggy bank. I don't know. But what ends
Yes.
up happening is that someone finds it, and then when you go look for it, it's disappeared, it's gone. Okay. So now you kind of more smarter, you are more wiser. You decide, but no, you know what? This 100 rand, I'm gonna go to the bank. So let's just say you were eligible. You got a bank account. So what you do is you go to this beloved bank, the bank of the people. Yeah, the bank of the people, Capitec. And you have every intention there to basically put your money away for the purpose of saving. And more specifically, we say or we use the word you want to invest that money, you know,
Yes.
with the intention of saving it and making it grow. So then Capitec, what they say to you is, hey, my guy, we love the fact that you've come to us. Well, we want to offer you this one-time offer, okay? And let's just say we are making this up, my guy. This is not going to be real life stuff. Capitec
Yes.
offers you 10%, and they say they offering you 10% simple interest, okay?
Yes.
10% simple interest. PA meaning per annum, or let's just say per year. All right. So what does that actually even mean? Okay. All right. So you have 100 rand. This is money that you have on hand.
Yes.
Capitec is like, give us your money. We will keep it for you. All right. And
Yes.
for us keeping your money for you, we will pay you 10% every year. That's where this idea of interest is coming into effect. Capitec is going to take your 100 rand, and it's not like that 100 rand they are just going to keep it for keepsake. They know for a fact they are going to use that money, you know.
Yes.
They're going to use it. So for the price of using the money that you've given to them, they are going to pay you 10%. But they are going to pay that 10% how often?
Every year.
Every year, my guy. Now. This is where you need to, for a moment, ask yourself the question: if we have invested that 100 rand, how much money are you going to be getting after the end of the first year? So this is the first year. It has 12 months. At the end of the year, how much money will you now have if Capitec is going to give you 10%? So my question then to you, my guy, is what is 10% of 100 rand? How much money is 10% of 100 rand? In other words, what's 10% of 100? How much is it? How much is that worth? Do you know?
10 rand.
Exactly, bruh. Okay. Yeah. So even for that is helpful, right? Because now you know how much Capitec is paying you for them keeping your money for a year. They are paying you every year how much? 10 rand. Which means at the end of the year, how much money will you have in the savings account?
110 rands.
It makes sense, ne?
Yes.
Now, when you go to begin the second year, in your account, you begin with how much?
I begin with 110 rands.
Exactly, right? And then what happens is that because the agreement of the savings account is that of a simple interest agreement. Simple interest, by definition, is the kind of interest that is earned based on the original amount. I repeat, simple interest is the sort of interest, okay, that basically you are able to make money year after year, but it is calculated based on the original amount. Right.
Yes.
So in year 2, I have 110 rand, but how much will I make in that year? The minute year 2 completes, all right, I'm still asking myself, what is what? 10% of
100 rand.
100 rand. I'm still going back and checking what is the 10% of the original amount. So that means by the time year 2 ends, how much money will I have in the account?
120 rands.
You get it, my guy. Then I begin year 3, the beginning of year 3, I begin that year with how much?
120 rands.
Exactly 120 rand. Then again, the year proceeds. Another year passes by. How much will my amount accumulate by? How much will I be earning in that year?
10 rands of simple interest.
Exactly, because I still ask what is 10% of the original amount. So that is simple interest. So that means by the time year 3 ends, I have 130 Rand in my account. All right. And that basically is that. So let's just take it up until year 3. Okay. Yeah. So what are we noticing with simple interest? One, I said simple interest is always calculated according, the interest is always calculated according to the original amount. All right. And so that means my money grows at a constant amount. All right.
Yes.
Every year I'm adding how much?
10
For
rands.
this scenario, we are adding 10
10
Rand
rands.
every year. Are we together?
Yes.
Yeah. So that is what, in short, simple interest is. Before you get into the formula, you need to first understand simple interest as per the definition. That simple interest is interest that is calculated based on the original amount. Okay, so we are always checking, okay, what is the interest rate? Okay, the interest rate is 10%. So for year 1, what is the percentage based on the original amount? Okay, that is the amount, it's 10 Rand. So that means for year 1, my investment is going to grow by 10 Rand. And every year, my investment is going to grow by how much? 10
rands.
All right, for this particular situation. But that applies to all simple interest situations. Okay.
Yes.
So I need you to first understand that. Okay. Do you have at least sort of like a bit of an idea now of what simple interest is? Maybe you can even go then to your definition that you have been given at school in your notes. You can read that definition and then try and make sense of it in light of what I have said to you here.
All right, let me check first.
Please go and check it out. Then you can read it to me, and then let's try and understand that definition in light of what I have said to you here, so that you can make sense of that definition, so that you don't misunderstand simple interest again.
Simple interest. I'm checking.
That's fine.
Oh, it is saying it's the money and in an investment or charged on a loan. It's saying it's the money earned on investment or charged on a loan.
Okay, and on an investment. So this particular situation, we're talking about an investment specifically. All right.
Yes.
But remember, sometimes it's not that you are growing money. Okay, an investment is all about saving and growing money. A loan, on the other hand, is about getting money, right, that you didn't have, but then you then have to pay back that money. All right. And that money that you pay back, when you eventually have paid it back, you will find that you will not have paid back that exact amount, but you would have paid back that exact amount and a bit of interest All right. Yeah,
Yes.
because the things work the other way around when you take a loan. When you take a loan of 500, for instance, that you don't have, it's not like when you when you pay back that 500, you will pay back 500 rand strictly. You will be paying back 500 with interest. Okay. So that is just a situation that is obviously not going to favor you, but it's going to favor the person whom you have taken a loan from. Okay. But I think in essence, I don't know if there's any other thing that has been mentioned as far as that definition for simple interest in your notes, because I almost feel like they didn't give you guys a. Is there anything else that is mentioned? Any notes on financial on simple interest?
Let me check. No, you just mentioned the formula and
Or the
like
formula? Which one? Which formula did they mention?
um let me write it. A A equals to P
Okay.
brackets 1
1
plus,
plus I times N.
yeah, items N.
Oh, okay. All right. So that is just the formula. All right.
Yes.
Yeah.
And like the meaning of the things on the like the meaning of the variables on the formula.
I see. I see. I see. All right. But okay, and I get all of that. But I think what's important at the foundation is just understanding what I've explained here for simple interest. Okay. Now I'm going to get into the formula and all of that stuff. But I need you first to understand what is the concept behind simple interest. So, like I said, this is interest that is basically are calculated based on the original amount. So you're always taking the percentage based on the original amount so that you can establish how much money is made year on year. And it grows at a constant amount, right? It's the same value in which that particular investment will grow by year. Okay, it doesn't change, right? Okay, then I want to look at compound interest. Okay. Okay. So that you can see the difference. Let's say we are speaking about the same 100 rand. Okay.
Yes.
You go to Capitec Bank again. This time around, the Bank of the People offers you still 10% per annum, but this time they say 10% per annum compound interest. Okay. Not simple interest this time around, but what? Compound.
Compound interest.
Yeah. So I want to show you how compound interest differs from simple, right? So that means when you start your investment, how much money are you having in the account?
100 rands.
100 rand. That is the beginning of year one, right? Then what happens is you finish that year, all right? And then
Yes.
your 100 rand is going to grow by how much? You're going to take that 100 rand, you are going to calculate 10% of 100 rand. What's 10% of 100 rand?
10 rand.
It's 10 rand. So how much is your investment growing by in year one? It's growing by
10
how much?
by 10
10
rand.
rand. So at the end of the year, how much money are you going to have?
110 rand.
Exactly 110 rand. Now, that's all well and good. When you begin year two, how much money do you have?
Starting off year 2, I have 110 rand.
Exactly. Thank you very much. Now listen to this and listen to this very well. Compound interest does not in year 2 when the year begins, calculate its interest based on the original amount. Rather, it calculates the percentage of the interest based on the new amount. Are you with me?
Yes.
So the amount grew, it became 110 Rand. So if we are going to now calculate how much this 110 will grow in the next year, we are not going to say 100 Rand times by 10 over 100. No, we are going to take the new amount, which is 110 Rand, and check what is 10% of that amount. Are you with me?
Yes.
Then what is it? What's the 10% of 110? You need to help me out there.
Of 10% of 110 rands, right?
110, yes.
11 rands.
Are you sure?
Yeah, I'm using a calculator.
No, that's fine. But I'm just always checking if you have typed in correctly. Everything is pashasha, everything is sweet. Okay, if it is, then that means in the next year we are having this new amount growing by 11 Rand, which means at the end of year 2, how much money are we going to have in the account?
I'm gonna have 121 rand.
Exactly. Okay, Justy, are you with me?
Yes.
Yeah. So when we talk about compound interest, we are talking about compound interest is not going to be calculated on the original amount. Compound interest is calculated based on the new amount year in, year on year. All right.
Yes.
So that's why they say it is another way that they usually mention when they talk about compound interest. They say it's interest on interest when they refer to compound interest. They usually say it is interest on interest because we are not always going back like the simple interest, going back to the original amount to check what is 10% of that. No, we are going back to the new amount to check what is 10% of that. Right. So we have 121 Rand at the end of year 2. Whereas if you remember, with our simple interest, we had 120 Rand. And I'm sure you can see that this amount compared to this one in year 2 is more than what we made when the account was actually put through the simple interest.
Yes.
Yeah. But in compound interest, it's that much more. Does that make sense?
Yes, sir.
Yeah. So that is very, very key. Very, very key to understand. Then let's go to year 3, my guy. Okay, just to sort of like wrap it up there. Year 3. Ne?
Yes, sir.
Year 3, we are starting off the year with how much?
121 rand.
121, my guy. Then we put our amount through another year of torture and pain. But the bank is there to pay us a certain amount for that year, which we can calculate, because what are we going to do when we're calculating that? We take the new amount, which is what? 121 Rand. We check what is 10% of that amount. And then we get what, my guy?
12.1.
Exactly, which is like 12 Rand 10 cents, in other words.
Yes.
We take that 12 Rand 10 cents, we add it to what?
To the new
That
amount.
121. What do we get, my guy? What's 12 Rand 10 cents plus that 121 Rand?
133 rands, comma 10.
100 and
33 rand, 10.
okay, 133 rand 10 cents. So do you see that if we compare this amount, compound interest after year 3, with that amount at year 3, which one is more?
The compound one is more.
Exactly. The compound interest investment is more. Okay.
Yes.
So I want you to note something then for yourself, Justy. In year 1, when we were growing our account using the simple interest approach, do you see how much money we had at year 1?
Yes.
Do you see how much money we had at year 1 for the compound interest?
Yes.
What do you observe about the amounts?
Like the amount is the same because like
Exactly. So what does that tell you about compound and simple interest after year 1?
um the 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 amount is the same because of the interest percentage.
Exactly right. We are still applying that original interest for year 1. Okay. Yeah. So if you are investing your money, if let's say when you have a friend and your friend chooses to invest his money using simple interest, and you guys invest your money at the same interest rate, let's say maybe at 10%, whatever that amount of money is, what you are going to both see, if you both will go to the bank after the first year, you are both going to arrive there and you are going to see that, Haibo, we have the same money. All right.
Yes. Yes.
Yeah. But what happens at year 2, my guy?
We
For
won't have
simple
the same.
interest, it was 120, ne?
Yes.
But for compound interest,
It was 121.
it's 121. So there is a slight increase in the amount of money made in year 2. Why? Because, like I said, for simple interest, we are still using the original amount to calculate what? How much the investment has grown. But for compound interest, we don't use the original amount, but we use what? The new accumulated amount. All right.
Yes.
Yeah. So you are only going to notice differences in your investments with your friend after year 2. Does that make sense?
Yes, it does.
Yeah. So I need you to grasp that concept, Justy, that simple interest, that's how it works. Simple interest, we always calculating our interest, the growth. We calculate the growth of our investment based on the original amount and applying that interest rate. But for compound interest, even though we do that for the first year, in the second year, my guy, we change it up, because we
Yes.
are utilizing the new amount and then applying the interest rate to check the new amount that our investment is growing by.
Yes.
Okay. Now, check this out. To use the formulas that you now I want you to tell me, you said that the formula you got for interest, for simple interest, according to your notes, is A is equal to P 1 plus I times
And
N. Correct, ne?
yes.
What does the A stand for according to your notes?
The value of investment.
The A stands for?
The value of investment.
Okay. All right. I just also want to add that A, even though you are saying it's the value of the investment, all right, remember that after year 1, this is the value of the investment. After year 2, This is the value of the investment. After year 3, this is the value of the investment. Okay?
Yes.
Yeah. So, in other words, this is a future value. Okay? Or the value after years have passed. So, after some time has passed, after years have passed. So some time must pass for you to get a, it's a future value. It's the value of the investment after a number of years. Okay, that is A. Okay, then P, what did they say P is?
The initial amount.
The initial. Do you know what the word initial stands for? What does the word initial mean?
Like the amount. What can I say? Like, let's say for example the money that you borrowed or the money that you invested.
Very good. Very well put. You couldn't have said it better. Okay. The
Yes.
amount, if it's an investment, if you are intending to save money, it's the invested amount. If you are taking a loan with the intention to actually pay back that money, then the loan amount is what we call your P. Okay. Yeah. So it's your initial amount. All of those would be initial amounts. Okay. So the P, more specifically, they use this word. They say it's called the principal amount. All right. Okay.
Yes.
But you've explained it well. It's either the amount that you invest at the beginning or the loan that you take out at the beginning. N, what does N stand for?
Number of years, the time period.
Okay, number of years, specifically number of years. So it means that if they give you the time period in months, you have the responsibility of converting months to
Into
years.
years. Yes.
Okay? Yeah. And how do you convert months to years, Justin? How do you do that? How do you convert the number of months to years? What would you do? If they said to you the investment for 9 months, after 9 months, what then does it mean? How will you convert 9 months and express 9 months in years?
Or 9 months in years.
Yeah. How will you convert months into years?
I don't know, sir.
You will divide by 12, my guy. How many months are there? How many months are there in a year? There are 12, right? So if you are given months, the way that you convert months into years is you will divide the number of months by 12. And then in that way, you'll be able to express your time period in years. So don't ever forget that, because it becomes useful sometimes when the examiners or someone who is testing you wants to check if this person actually understands what they are doing. So we don't
Yes.
substitute into the formula, this formula, unless our N is in years. So if they give you months, you must know what to do. If they
Yes.
give you days, you must know what to do. If they give you
Yes.
weeks, you must know what to do. Okay? Yeah,
Yes.
I'm just putting it out there. Okay. Yeah. Right. Then lastly, I. What is I? The small letter I.
The interest rates.
The interest rate, exactly. It's the interest rate. That interest rate of yours, all right? There are two things. I, as an interest rate, is expressed as a decimal number. So what you will notice is that If you are expressing interest rate as a decimal number, it's small letter I. So what they usually do is I is equal to R over 100. The I is the interest rate expressed as a decimal number, not as a percentage.
Yes.
R, on the other hand, is the interest rate that is expressed as a percentage. So if you want the interest rate, I, small letter I, you are going to take R, which is the interest rate as a percentage, you will divide it by 100. Then you will have the interest rate as a decimal number.
Yes.
Yeah. If you want to express the interest rate as a percentage, then it is R. R is equal to the interest rate as a percentage. So if you are given the interest rate as a decimal, all you do is you simply multiply it by 100 and then you'll have the percentage. Okay?
Yes.
So I am repeating. The interest rate I is the interest rate expressed as a decimal number.
Yes.
Are you with me?
Yes.
Yeah, not a percentage. So what you usually do to actually show that I, small letter I, is you take the percentage, which is R, you divide it by 100. Just like, for instance, we said, Mosi, 10%, now 10 over 100. That is the interest rate expressed as a decimal, which is what? 0.1. That is I, decimal number. Okay.
Yes.
But if I was to express that interest rate as a percentage, it is not I, it is R.
Oh.
R is 10%. Okay.
Yes.
Yeah. So please, my guy, the small letter I is R over 100. That's why sometimes in the formula you'll find some people will prepare the I before they substitute it into the formula, and they will put the 0.1 already prepared, 10 over 100, 0.1, they will substitute it into the formula, or they will take the 10 over 100 as it is and put it in the place of I and multiply it with the n, and then put it in the calculator and solve.
Yes.
Are you sure, my guy? But it's yes, you are getting it.
Yes.
What A is, what A is, what P is, what N is, what I is, small letter I, and therefore the dynamics that are involved around I and R and how to express each.
Yes, I do understand.
This is the formula that we use in situations where we are given an initial amount P, and maybe they want us to calculate A and we are given I and N. Maybe they want us to find out what is the value of the investment after 7 years. We can use this formula. Or sometimes they can give us the A value, the value of the investment after 7 years, give us how long it took, and give us the interest rate. And then they want us to calculate what was the initial or principal amount of the investment. So there's many things that they can ask us to calculate. We can be asked to calculate A, or we can be asked to calculate P, or we can be asked to calculate N, or we can be asked to calculate I using the very same formula.
Yeah.
Okay. So when you read a situation or a scenario that they give you, you must be able to read and then point out, oh, there is my P. And you must be able to, based on what you've said to me, I think, just I can say, when you seem to understand very well what A is. The fact that you're able to explain, no, A, sir, is the value of the investment. To me, that says you understand. But it's also important to then understand that after a certain period of time has passed, we talk about an A value. All right?
Yes.
Value of the investment. Yeah. P, at the beginning, when you start, that is the initial amount, the principal amount. If it's an investment, that money that you invest in the bank. If it's a loan, that money that you borrow from the bank, that you don't
Yes.
have. You want to buy a car, you borrow 200K. And then what happens is that you have to pay back that 200K, but from whoever you borrowed 200K from, they will charge you certain interest rate, and you will be paying 200K and more to actually then be able to make sure that you are keeping that car whilst at the same time meeting the needs that the bank have. Does that make sense? So
Yes.
that's P. N number of years. And I think we've spoken about the fact that if they give you in months, you must be able to convert, because sometimes they want to trick you. They give you the time period in months, and then people get stuck. So you must be able to convert. Know how to convert between weeks, months, and so forth, so that you are in the position to express the time period in years. And then lastly, interest rate. I said small letter I, small letter I, small letter I is the interest rate that is expressed as a decimal number. That is small letter I. But, and when you write it, that's small letter I, you take the percentage that you are given, you divide it by 100. That is why small letter I can be written as 0.1, not as 10%, but as 0.1, because like I said, small letter I is the interest rate expressed as a decimal number, not the percentage. They
Yes.
are the same thing, but it's just that small letter I is expressed as a decimal number. Then R is also the interest rate, but just expressed as a percentage.
Percentage.
Yeah. Okay. All in all, I and R are the same thing, just that they are expressed differently, and hence we appoint different small variable letters to indicate such. Okay.
Yes.
Yeah. So that is simple interest, that formula. But even for compound interest, do you have a formula there for compound interest, my guy?
Yes.
Give it to me. What's the formula?
A equals to P,
Uh-huh.
a bracket,
Uh-huh.
1,
Uh-huh.
1 as I,
Uh-huh.
brackets,
Yes.
exponent N.
Exactly. And I'm not going to repeat what I said. Everything I said applies. A is still the same thing, P is still the same thing, I is still the same thing, and N is still the very same thing. It's just that the formula has an exponent N outside the bracket. It's not multiplied with I, and that is the difference. Okay. So my guy, that's all I have for you today.
Okay, thank you.
Yeah. And I hope that you will then use that understanding to then assist you and help you, because this, like I said, was just for the purpose of explaining, so that you can understand what simple interest is, what compound interest is, what makes the other different from the other. Then this here, it's easier to calculate all of this if you use the formula, right? For simple
Yes.
interest, if we wanted to know what the value of the investment, same 100 Rand, which is P, for let's say 3 years this time, our time period, N, and then the interest rate is 10%, we would say 0.1 times 3. You would see when you substitute in here, your A value will be exactly 130 Rand. All right. After 3 years. Does that make sense?
Yes. Yes.
Yeah. And if we were calculating compound interest, instead of doing all of this step-by-step stuff, we just use the formula, we'd still get the same A value after 3 years of 133 Rand 10 cents.
Yes.
Just by using the formula. It's straightforward. This, what I did here, was to help you differentiate between compound interest and simple interest. Because as I said, you need to understand that simple interest calculations are based on the original amount, whereas compound interest, it's not based on the original amount, but on the new amount that you have year after year. Okay.
Yes.
Yeah, Guy. Thank you for your question. It was good. I really appreciate you. Uh, Hopefully, we'll run into each other again on the streets.
Yeah.
Yeah.
I appreciate you. Thank
You
you.
are welcome, Justy. I appreciate you asking the question and having the confidence and the boldness to do so. I have
Yes.
much respect for you because of that.
Yes.
All right. Cheers, Bob. Cheers. All right. Yeah, that was epic. I think that was epic. So we've looked at two things today. Someone came up, asked about exponents in grade 8. Um, yeah, even though grade 8s are not even there yet, but very interesting. I thought that was very interesting. I see some learners are very busy with their lives. They don't mess around. Content, uh, subject content is important. Hopefully, we will have people doing amazing things in the future. Then this particular learner in grade 9 asked a question on financial maths, because I know grade 9s are busy with financial maths, direct and indirect proportion, all those nice sweet topics there at the beginning of the year, real number system, yeah, that nice stuff. Eh? Grade 9s. It's nice stuff, term 1. Okay, so yeah, man, don't miss it. All right. I know above and beyond compound and simple interest for grade 9s, there's things like VAT as well, exchange rates, um, commission, yeah, commission, yeah, and all these other things that are there as well for financial math. So, yeah, good question from Justy. Really appreciate it there. I think, yeah, hope everything of the best for that particular layer. Yeah, guys. I'm here taking people's what you might call questions. It's just that people here I can see, um, yeah, people here are just yeah, yeah. But yeah, I appreciate and really want to thank. I think I got a rose from someone earlier on. I missed that, but thank you so much to that person. Please, guys, if you are here and you are liking what you are hearing, it would be great if you could support there. Yeah, I have my 2026 goal there. Life goal is, yeah, guys, when you support, it's appreciated, as I said there in the comment section. If you are in grade 8, 9, 10, 11, you have a question, I'll be happy to take a question. If there aren't any, then I guess, yeah, there aren't. It is what it is.